So we have covered a bit of the basics, and the savings on our road, so we're going to zip through that. Okay, we got the savings here for sure, and it is very, very, very circulate what you are looking at savings. If you're boiling down raw sap, or you're boiling down 8%, of sugar content, what we call 8 bricks, or 10 or 12, it's kind of fairly easy to figure it out. And we're going to talk a bit about math. So to a high school to get those math back into your head, so that you can calculate pretty much everything you need to know about an RO. So 75% in boiling time saved, that's from 2 to 8 bricks. But when the season gets down to what it is, late towards the season, we still like to boil that sap, but very often it's down to 1.2, 1.3 bricks, And from there, it's a very, very, those are not a big difference in number, but it is a tremendously big difference in sugar content. If you compare 2.2 brick sap, raw sap, from 1.1, well, sir, there is half the sugar in there. So that means that there is twice as much water than there is sugar. So in order to turn it into syrup, you're going to have to boil twice as much, from 1.1 to 2.2, and this scales up. So you see it right there at 2 bricks. So at 2 bricks right there, you see the curve, the difference curve, and I don't want to spend too much time on this, but again, what is the nerve of the war? The nerve of the war is really to get to 10 bricks, You see it flattens out from there? So if you ask me, and some people will tell you, Carl, you don't need to talk about that, we love to have high bricks RO. Yes, I do love high bricks RO too, but what is, depending on the size of your operation, this is the place that you get the big savings. From 2 to 8, you just pushed 75% of the water out of your sap. And if you go from 8 to 10, you get about another 7 to 10%, and it flattens out, So yes, going to 16, 20 bricks is nice, but is it worth the investment for you? You got to calculate that. If you got to put $7,000 in your machine to save another 10% of your boiling time, if you're boiling only 4-6 hours a day, is it worth your money? Alright, so that is all thing that you can figure out and you can calculate by yourself or with the help of one of our representative and dealer. So, but of course, high bricks is very profitable when you scale it up. Alright, we will not be boiling down 140-something thousand taps at 12 bricks, and we're talking thousands and thousands of dollars of fuel and time. So that's for you to figure out. What is your sweet spot. And the RO principle is very, very simple. The RO, by the membrane, it's more of a membrane element. The membrane is the film inside that lets the water go through, but not the rest. And like Bev said, there are hundreds of types of membrane for different application, and we use very tight membrane, what we call reverse osmosis membrane, and you have very, very tight membrane, so we keep all the minerals. There will always be trace mineral in the permeate, but it's very acceptable when you're talking less than a percent of a percent. So membrane, the way it works is by the effect of pressure. It will push the water on the other side. Of course, the higher bricks you go, the more pressure you need to fight the osmotic pressure. I don't want to go too much into details. I don't want to make a rocket scientist out of you today. I just want you guys to understand well how to run your RO, to size it, and to take care of it. So the principle behind RO is very simple. You get a feed pump that will pump right around 60 psi. I gotta stop on this again. Don't do like some people and modify your RO to put a feed pump that go, let's say, 120 psi like some of our competitors do. It's just because they didn't read the spec sheet of those kind of filters. Those kind of filter can run good up to 40-45 of pressure, 40-45 psi of pressure differential, and the machine stops at 20. So if you pump at 60-65 psi and the machine stops at 20, you're still within the parameters of what the filters are capable of doing. But if you push 100 and you still stop at 20, well, now you're at 80 psi of pressure differential, stuff will just go right through those filters and into your membrane. And this is a couple dollar filter. This is a $1,000 filter. Which one do I want to kill, you know? Makes sense to me. So be wary about filtration, very important. So pre-filtered sap goes through the membrane from 250 to 450 psi. Well, that is true for regular RO, but when you're talking hyperbricks, we will go up to 800 psi and even more. Of course, the machine can split the sap up to 90%. With a regular RO at those pressure, that should be about the maximum that you would get out of an RO. You could get more, but to a point, it will not damage the membrane, but it will foul it too rapidly. It will foul it faster, and you won't be able to run a normal day. You know, to me, a normal day of running an RO is somewhere around, 8 to 12 hours. That should be your average. If your average is 16 hours running the RO on concentration cycle, well, sir, your RO is too small. That's for sure. And reduce your concentration time right around 10, 12 hours. Because 16 hours it will overfoul the membrane. So from there you'll have trouble getting back to performance, and you're going to hinder your RO from day one to the last day, and right in the middle of the season the RO is not big enough, it's not processing enough sap anymore for you. So please make sure you run your RO accordingly. So right here, this is just schematics of what an RO looks like. And I don't want to spend too much time on this, but of course you get the feed pump, you get the pre-filtration, the high pressure pump. I want to talk a bit about that. That thing here would be exactly that thing there. It's the pressure bypass. That's how you adjust your pressure. But it doesn't modulate the pump, It's just a bypass. You can clearly see it from here. If the high pressure pump pushes pressure in there, and I open that valve, some of that pressure is going to go back into the feed, right? Right, makes sense. But so that valve, when you're running an RO, you want it as much closed as possible. As much closed as possible. I've seen horror stories, an RO running with a 10-gallon pump on 4 membranes and achieving 16, 18 bricks. And you get the guy say, okay, you look at the flow meters, you get about 1,200 gallons. I know that those 4 pumps, if we use it fully, will deliver 2,400 gallons. So I asked the guy, and can I play with your RO? He said, of course, it's your name on it. Do whatever you want. So, okay. So I stopped one pump, closed down that valve, got back the exact same pressure, exact same number. Stopped another pump, closed down that valve some more. Exact same pressure, exact same flows, exact same concentration. So you had 40 amps running around in there. It's a good waste of energy, and if you run, if you have run an RO with that valve, let's say fully open, it's probably because you got one pump running too many. Okay, so you want that valve as mostly closed as possible, because running around in there, out of the pump back into the pump will slowly degrade that sap because it's heating it up. So from there, of course, it feeds into the membrane vessel. Membrane vessel, you get 2 outlets, one for concentrate, one for permeate. Permeate, from the effect of pressure, will be pushed inside the membrane towards, there are multiple coils in there. Okay, it doesn't go from one coil to another to another. It's like having multiple paths. So under the effect of pressure, it will find its way from the, sap goes in. Our recirculation system is working on suction, not on pressure. And the reason is very simple. There is a limit to vacuum. There is a limit to vacuum. Vacuum cannot be more than the absence of pressure. But there is no limit to pressure. And running an RO like that, if you create too much pressure and you're trying to make it over permeate. Let's say I could make an RO with a pump in there that would, be something fierce, and you would get 8 gallons a minute of permeate out of the first membrane. And people will say, oh, that's a very performant RO. Yeah, it will last for about an hour, then go. Yeah, simple like that. I've seen some competitors and some people that likes to, jimmy rig around their RO, trying something, say, why don't they just put more pressure in there? Well, so that's why we put a 3/4 HP in there, and not a 5 HP on the recirc. You can do that. It will look good the first hour, but it won't last. You know, there's a limit to it. Just like, you know, we want an RO to be able to run a steady pace at a, you know, that we can figure out, you know. You say, oh, my RO will process about that, and it will run like that for about 8-10 hours. And then slowly start going down. So that you can predict your dig. If you have an RO that will run very good for 2 hours, then poorly for 4, then about nothing for the last 4, you don't want to stop every 4 hours to wash that thing. You'll be constantly playing with those buttons and those valves. You know, you have something else to do, like being in that bush, making the sap come down. So from there, permeate goes out to a flow meter to measure the amount of it. And the concentrate gets out there. There you got another set of valves. The same valve that you have there. You got the concentration valve and the wash valve. This again is just a bypass, but it's not adjustable. You know, it's open or closed. So if I open it, of course nothing will go through that needle valve, right? So this is your wash valve. When you open it, you make sure that there's no pressure into the system because you cannot wash under pressure. You RO under pressure. So once that it's closed, everything has to go through that needle valve. And I like to give that quick example to explain how does that work, how that thing works. Let's say right here, we got a nice place. But let's say that we are coming in from this door, okay, which is wide. We can be like 3 guys side by side coming in at a steady pace. And then we have to go out through this door at the same pace, but only one guy at a time can go out, right? Then we're going to get to much bigger population density very fast in here. Because more people are coming in than people can come out. So what will happen? Eventually people will be pushed out the windows. That's your permeate. People being pushed out the windows. And your concentrate is that door. Your concentrate valve is that door. So if I close the door, even less people can get out, more people get pushed out the windows. So that's exactly how it works. It's a lame example, but that's exactly how it works. So from there, of course, the pressure, the high pressure, you know, the big gauge there, is measured after all the membranes and before that valve. And you have another flow meter there to measure the amount of, the volume of concentrate you have. How does recirculation work? Well, for Lapierre, it works, like I said, in suction, in negative. Some other brand will have a kind of a piggyback pump on the side and try and have the sap run in the vessel. And some other will have positive recirculation to push instead of pulling the sap to create recirculation. What's the difference between those? Well, if you ask me, you know, kind of piggyback recirculation, those are just underperforming. They're just not very good. Direct recirculation is the way, you know. You take the membrane and you sit it on the pump. So that's pretty good. So then you have positive and negative recirculation. What does it do? There's only 2 ways to crush a membrane. And of course, one of these ways is very rarely occurring. Okay, so let's say that the system is not fully flushed, there's still air in the system, and that pressure valve that we were talking about is fully closed, and you go boom, starts 3 pump at the same time. So the membrane is full of air, there's no pressure within the membrane, but the outside gets high pressure real fast. It can crush a membrane, but that rarely happens. What happened most of the time? Membrane should be 400 psi too. Not inside the permeate tube. There should be no pressure or very level in there. So as the sap goes on top, you know, to recirculate, and again, and some gets out of there, it loses water, right? Because it's ROing, it's losing water. So if you have 400 on the side, here on top you still have 400, and a bit further down the road you might have 399, 398, 397, and back in 400. Because it's suction, right? It's losing water. But what if my membrane is clogged by that goo that we all love, you know? That goo in the sap that jams our filters and makes everything worse. What if that membrane, you know, there's a spacer in there, what if it's clogged? Well, it's clogged the feed. It's clogged the way that the water travels, the sap travels up down the membrane. But it doesn't mean that the membrane itself is clogged, you know, the film. So it can still RO, but the water has trouble getting inside the element. So as it's losing water, it's losing pressure. But water cannot find its way back in fast enough. So then, instead of having 99, 399, 98, 97, and maybe 96 in here, all right, you might be down 5, 6 psi, 400, 398, 395, 393, crush the membrane under the differential of pressure. So if that happens, it's because you had a membrane that was overfouled. That's the simple reason. Simple reason how it happens. And it will happen mostly when toward the end of the season, not the beginning of the season. Your membrane usually stays fairly clean beginning of the season, but when it gets gooey, you gotta take more care you wash, So recirculation happens like that, and that's what is the nerve of the war in the RO. Before we had good recirculation, we needed crazy amount of membrane to achieve maybe 4 or 6 bricks. Some of you have probably seen those old monster giant ROs osmotics used to make in the days. And in order to process 600 gallons of sap, you needed like 12, 16, 4-inch membrane, all in series. So sap would go in one, go through it, lose the water it can under the pressure you were pushing it to, and then back to the other membrane, and again back to the other membrane. Only one pass in each membrane. So with recirculation, we're creating multiple paths for the sap to lose water. And not only that, since we're creating multiple paths, the sap goes very fast in there. That's what we call tangential speed. Okay? So in your old system without recirculation, sap would go very slowly in there, and it lose what it can. So it had time to deposit stuff and leave stuff along the way. Now since it's going so fast in there, well, membrane keeps cleaner longer, so that's why we can run up to 10, 12 hours and lose very little performance on a normal day. Why Lapierre RO? Well, there are a few reasons. First thing, we're the lowest power consumption RO in the industry. Nobody comes close. And I'll tell you why, very simple why. Because we know how to use our pumps. We don't, simple. We know how to use our pumps. With the specs and the size of everything was calculated down to the last iota in there. So we don't need to have more HP to do the same job than some other. So power consumption to me is one big thing. When you're talking small RO, it's not that bad, that RO that draws maybe 5, 6 more amps. That's not that bad. But when you're talking big system, you're talking 100 amps more. That is a lot of power. I need less than that to run my house. Simple, reliable, it's got safety features, auto shuts off by pressure, as soon as the machine gets under 20 psi it will shut off, and auto shut off by temperature and high pressure shut off. So, like Bev said, high resale value. It's very hard to find a used Lapierre RO. Good luck to finding a vessel. We have a few back at the plant, and most of the time there is a list of names to get some. So our own in-house made high pressure pump so that we can service them fast. We'll always carry all the parts. We at Mr. Brackenridge and a few other places, we carry loaner pumps and loaner, not loaner like loaner in the corner, but loaner that you can. No. It's a loaner pump for high pressure and recirc pump. Feed pump rarely go bad. One thing for sure. What I think about it, please put a Y strainer in your feed pump, not to find a mouse in there. I would also recommend to put a pressure gauge just after the feed pump. So you got your, feed pressure right here, okay? That's what we call the low pressure. That is measured after the filters. So it tells you the pressure that is left after filtration. But the pump always gives the same pressure, right? It's like that, it's a pump. So if you have a gauge before the filter, thus on the pump, you'll know exactly if something goes wrong with your pump. Because you'll be used to see that pump running at 65, 60 psi, And then one day you're coming in and you have trouble starting your RO, and have trouble having high, good feed pressure, and go, oh, my filter must be dirty. Well, if you have a gauge on the pump itself, and you go, it's only delivering 40 psi. Oh, something's going on in there. And believe me, I serviced those machines for quite a while in my early years. You knew how much stuff I got out of those pumps. Plastic shards, those end towels, squirrels, mice. Mice are very, very popular in feed pump. Bendability system, we're gonna go very fast. Our RO were designed to be modular so it can grow with your farm. And I would always recommend, let's say you start a brand new operation. Always think ahead. Always think ahead. Is there more taps that I can put my hand on? But let's say you figure it out from start. I'm going to get a bit bigger evaporator, but I'm going to be on the lower side of concentration. Then as I get more tap, if said thing happened, I can just expand on the RO higher bricks, and you see that evaporator getting bigger and bigger on you, but it's not changing size. It's just that you push more concentrated sap to it. But there's a limit to that, because then you got to care for the evaporator ratio, and we're going to talk more about that later on. But you get a 2000 series like that, can go up to 1200 gallons pumping on 4 membrane. So you can start small and grow bigger. And a 3000 series, this one, you wish only with 4 membrane, but that is our standard, but we can put up to 9 membrane on a 3000 series, big one like that. Of course, you'll need the pumping, to add the pumping to keep going with that. And lots of different options, and again, those are the bare minimum to keep everything functioning. You can have extra outlets, and those are cheap. If you get an RO with a 600, please save yourself some time and issue. Get the 2 extra outlet to get up to 3. Our outlet works in triple. Yeah, work in triple system. We got 1 magnetic contactor for 3 outlet. So the 4th outlet would need its own magnetic contactor, thus it's more expensive. But the 2nd and the 3rd outlet is very cheap. You have those 2 outlets for about $300, not each, both. So it's very cheap, and it's worth it, because at one point you go, that I need to go higher. I got the neighbor's sap because that's sick. That happens. So you get your neighbor's sap. You got to boil it down. But now your RO is small, so you can just call your dealer. Oh, bring me a vessel. Bring me a vessel. He brings a vessel membrane. You didn't double up, but you will get more performance just by adding a vessel. Okay, and that booster pump is something that should be an hour talk by itself, but to make it short, when you have a long series of membrane, let's say 6, 9 membrane, we put a booster pump at 2/3 in the series to reboost the pressure towards the end, because the sweeter the sap, we talked about that, the sweeter the sap, the more pressure you need. So that's what the booster pump does. And then you got the permeate kit. That I like. It's very cheap. It's a small simple valve. I hate mics. Okay, small simple valve that we put on top of each membrane. If you have only 1 membrane and you want to test your permeate, well, you test it at the outlet. It's only 1 membrane. But let's say you have 3 membrane and you want to test for sugar leakage. Well, it's fun to be able to test each an independent membrane. So that way you don't have to take the pipe out, try and get a sample of that one to figure out which one is bad. And of course, multiple wash tank for filter mounts and whatnots. Oh, I want to take a few minutes to talk about this. Our pumps are, our high pressure pumps are all 5 horsepower. But we got a model in 20 gallon and a model in 10 gallon. We're in there. Now, very simple why. We want this to shut down at a low pressure. Those pumps were really made to originally for big RO system, okay, that we want still to save the power, but for big RO system with a booster down the road, So that way we don't have too much pressure in the feed, you know, early in the serial membrane, and then we just reboost it in the back. Okay? And of course, that if you run right around 325, 330, you would have a solid 20 gallons. So for the same HP, for the same power consumption, it is worth 2 pump. And you know, in a long series of membrane, in order to achieve high breaks, let's say we're talking 20 breaks, well, you don't want too much pressure in the front, and we talked about that, because then your first membrane is going to over-permeate, okay, maybe membrane, by the way, a membrane, and until it changes, okay, until new technologies or whatnot changes, a membrane should not be permeating. If you measure the permeate coming out of a single membrane, should not be more than 5-6 gallons. Some people will do 7-8 on the first membrane and 6-7 on the second, and it goes down towards the series like that, right? Depending on your concentration level in your series. But if you over-permeate the first membrane, it's gonna fall faster. Then the jump will be pushed toward the second membrane, then toward the third membrane, and you're gonna overfoul your system very rapidly. So that's why we keep low pressure in the front, and we reboost the pressure in the back. Because the best RO, the perfect world RO, each membrane would have its own booster pump. That you could fine-tune the pressure to get the maximum out of your membrane without over pushing it. But that would make a nice RO. But again, complex to adjust, and very expensive. So we kind of went the both of best world. So the 10 gallon, you know, can go up to 500 psi. And again, we can talk a bit about that. Some people tell me, yeah, but you know, Carl, if we put low pressure, the membrane don't fall as fast. Oh yeah? You're talking time here, right? Okay. Let's say I got an RO system, the exact same RO system. I compare two situations. Same SAP, same everything. And then I run it to 475 psi, from 2 to 8 breaks, let's say. It's going to take that much time to process that 2,000 gallon of SAP, right? And then I take the same RO, the same SAP, the same 2,000 gallon, but then I run it at 350. It's going to take more time, right? Makes sense. It's not ROing as hard, as fast, because of the less pressure. But still, exact same numbers, you know, breaks, concentrate, and everything. But in the end, that RO is gonna have processed 2,000 gallons. Okay, rule of thumb. About one, you know, you got your 600, let's talk about those 10 gallon pump. You know, it's a 600 gallon per hour pump. And a nominal of a membrane is 600 gallon. So for low concentration, you would want to have the same amount of pumping as you have amount of membrane. All right? If you're talking high concentration, you want to have twice the amount of membrane for what you have for pumping. Okay, so 2 to 8, same pump as membrane. 2 to 16, double the membrane. But the rule of thumb is 1 membrane per 4,000 taps, 45,000 taps, okay, at low concentration. And a high concentration, you're talking 1 membrane per 25 to 3,000 taps. You know, but you cannot achieve high concentration with 1 membrane. You cannot. Unless you go for a small, sweet 250 like that. Because since those are tiny membrane in there, you know, those 4-inch, instead of being a 600 gallon, those are 125 each, 125 gallon per hour. But those are so awesome, they actually, you know, a 600 rarely process 600 gallon of SAP per hour. It's a nominal number, you know. But those 125, they do 125, and I've seen some doing over 125. Yeah, so for a smaller scale system, this is a sweet RO because it's 2 membrane in a row in a series. So I've seen those machines process about, you know, almost 200 gallon of SAP per hour at 12 bricks in fair SAP. That is awesome. That is an awesome small RO, but it's not expendable as good as the other. Okay, let's keep going here. RO room. Bev talked about it. Over your heads here and there. So of course, RO room, insulated. If you run your RO electrical, if you run your RO on a generator, make sure you have the right voltage. Under voltage, over voltage will burn those motors. That is very, very important. Okay? If you run your RO on the electrical panel, on the hydro, once you set up your panel, try and foresee the future. Try and be a seer about your operation. Because I've seen so many guys have to have the electrician come back, redo the entire panel because they're maxed up to amp. Always. So when you start, doing it right the first time and keeping some space in that panel makes sense. Because you're always going to add stuff, always going to add stuff. So if you make it nice, tidy, straight, and you label your things, a Sharpie costs nothing. Permeate, drain, concentrate, drain, wash, and so on. Then anybody comes in by following those 14 simple steps. If the valve system is clear and easy, anybody can run an RO. Maybe not perfect, maybe not maintain it perfect, but anybody can. But again, tanks are very, very good insurance. So it should be at least 2 times bigger than the amount of taps. You have 4,000 taps, 8,000 gallon. You have 2,000 taps, you have 1,000 taps, 2,000 gallon. Concentrate tank, well, again, how high do you RO? If you RO, to 8 bricks, you know that you're going to keep about 25%, right? So you need about a quarter the size of tank. But if you're ROing to 12, you're going to keep about 80, you're going to be left with about 15-17% of that sap. So you can balance the size of your concentrate tank with that. And of course, the concentrate tank never need to be big because you don't want to store concentrate. You want to process it as fast as you can. And permeate tank, again, the more the merrier. But there's a limit to it. You would need, I usually recommend to have a minimum of 400 to 500 gallon of permeate tank, okay, for a regular small RO, because you want to have some left, But the more, the better. The more, the better. This valve panel was doing concentrate and permeate. Now we're going to have 2 small panel, one for concentrate, one for permeate. Because brass is a thing of the past now in the maple industry. We've got to get rid of it. So this I want to zip through this. So any RO would have drain on the concentrate and the permeate side would have an outlet to the wash tank on both sides again, concentrate and permeate in order to do that closed cycle wash. And of course you have an outlet to both tank to keep your permeate and concentrate. I would recommend that you put another valve on, by the way, on our new valve system, you could have 2 outlets for the concentrate and the permeate. So one can go back to the raw sap tank. When you start your RO, okay, it's not sweet yet. And I don't want to dilute that concentrate tank. I want to have it perfect bricks. So the evaporator, when I'm set and I know it's run, it will be constant. So I don't want to dilute that tank. So when I start the RO, I will send it back to the raw sap tank, all right, for a little bit while. And when I'm close to what I want, I switch it to the concentrate tank. Same thing when you do your concentrate flush. The RO just stopped. There's no more sap. Well, if you do your concentrate flush and you send it to the concentrate tank, you will dilute it. Especially towards the end of the day, because that tank is probably going lower and lower and lower. So you can send it back to the raw sap tank. So I would recommend, once the RO stops, you do a quick cleaning of your raw sap tank, to drain. And then you flush back to it. And you will dilute it a little, all right? Because it's going to be maybe 8 bricks to begin with, then it's going to go down to 0.1 bricks, and that's about where you want it to stop. You want, stop pushing it there. So the total amount of water in there might be only 1.2 bricks. But it won't be, 200 gallon. It will be maybe 175 gallon. So then, and since it's so thin, it won't go bad overnight. And the next day sap starts running again, it will just mix with it and it won't change much, to the raw sap, because the volume is so small.